Let's give it another minute for people to join.
Okay, maybe we can get started. See, Jai is here.
Yeah, just a sec. Yeah, I think. Let me share my screen. Okay. So you have my screen. Let's see. I think we have enough of a quorum. Let's start. So welcome. This is a second edition of this community meeting. We did a round of introduction last time, so we won't repeat that now. I'm Danny from IBM Research, and Maroon and I are leading this SIG discussion. I just wanted to do a very quick repeat of the scope of the discussions here. As we view it, there's kind of 4 topics in the scope. The first one is offloading KV cache. So it's all about KV cache handling and management. The first topic is KV cache, local KV cache offloading from GPU to CPU. This is mostly inside a single VLLM. Second would be indexing of what's happening in the GPU and CPU, and this is a global view. This is mostly first and foremost for routing, but also for the possibility of sharing between nodes. So just that VLLM engines will be able to be aware of where things are one on the other. So the second is indexing. The third one would be actual sharing directly between nodes, probably via Nixel or some mechanism that talks directly between nodes. And the third one would be storage, and storage will divide between a shared storage, which everybody sees and is a sharing mechanism, and local storage, which is closer probably to the offloading of CPU to GPU, but can also be viewed as. So these are kind of the 4 areas. And anyone who wants to add any topics of discussion for the talk today, you can either raise your hand now and we'll add them to the agenda. So I'll give it a sec.
Danny, if you share the agenda file, people can also just add, right? This is editable.
Yeah, we already shared the agenda. It's on the Slack.
Okay.
On the Slack meeting, but I can also share it here.
Share it in the
okay,
chat.
Maru just shared on the channel. Perfect. So, if we don't have any topics, let's start by going over the active work streams that we have. So this would be kind of a quick status update. We discussed some of them last time. So let's start with the KV disaggregation, the VLLM play. So CPU offloading PRs or is leading this effort. So, or do you want to update?
Yeah, so this week, since last time we met, continued to work on one of the PRs involving changes to VLLM flow between the scheduler and the workers. So I got reviewed from, I got one thorough review and had the discussions, and then just now I submitted a follow-up, and also opened another PR. So already I think something like 6 PRs about this feature. Yeah, but still work ahead.
Okay, and the 6 PRs are like basic preparation for the actual big PR that's gonna actual build the offloading, right?
Right. I think I got one comment on the RFC that I opened in VLLM, asking me if there's already a branch where the entire feature is available, so it can be tested. Started to be benchmarking, and so it's not yet ready. But I'm definitely I'm guessing that before these PRs will be merged, we would be testing, and I will let people from the community test it. It will be also useful because we don't have a lot of benchmarking resources available here. So if other people would be able to test it, it would be great.
Okay, good. So any questions?
Just to one point, I think that for the PRs that we already have, maybe we should add the links here to the document, and whoever is able to do reviews, it will be great because it will help us to push it forward.
Again, these are PRs in VLLM, not in the llm-d repository. Okay, so next topic is the KV Cache Manager. Maroon, do you want to take it?
Yeah, so overall there is maybe 2 major work streams ongoing in the KV Cache Manager repository. One being the KV events-based indexing. So a reminder to everyone, on llm-d launch, we implemented indexing and offloading through LM Cache. There have been requests, or we thought that it should be also possible to have the simplest form of offloading and indexing that is purely within VLM, while obviously integrating and continuing the support of LM Cache. So these are the open work streams. In the KV Cache Manager, there were two PRs that restructure the code a bit and prepare for the landing of events or indexing of the events already merged. A third PR, which is in final testing stages, that connects VLM or the KV events API in VLM to the global indexer. I want to raise a topic here on standardizing KV cache indexing or KV events-based indexing, since at the current state, VLM, or if you go outside of VLM and even inside VLM, you're sort of dependent on internal choices such as hashing packages, KV event schemas, and such. And we feel the need to start talking about standardizing KV events or KV cache indexing solutions. And this is something I wanted to raise, and I see that Jai is here from LM Cache. This is something we want to start looking at, considering that we've also got contact from Alibaba members or Alibaba Cloud members in the community who are building on top of llm-d, and they're interested in this functionality. So what I want to raise here is, or prepare for the discussion, which will come in the open forum. We'll leave that a bit. I'll update on the second work stream and come back. The second one is OpenAI chat completion support. I don't see Guy here. Maybe Guy can update after I give an introduction. So at the moment, at the current state, KV cache aware indexing, it works only for the completions or for the OpenAI completions API. Since chat completions, or since this requires some background, I'll take you through a very brief introduction of the KV cache aware pipeline. So a request comes in, the request is tokenized, the request then, or the tokens then go through the same prefix caching mechanism as in VLM. So they're chunked, they're hashed, and then you basically have the same indexing data that resides within VLM. So we recreate it in the KV cache indexer. When it comes to chat completions, there is a pre-step before tokenization, which is templating the different or some fields in the message, such as choices that contain the results of the generation, the history in its specific format of assistant, user, and such, tools and tool choices, and I think that's it. So these go through templating before tokenization, and that's what we're recreating here. I think this is also in final stages. Maybe if guys here, you can update on the state. Let me see if guys here.
No, I don't think Guy is on.
So this is also in final stages. The approach was, we looked at different options. The templating actually occurs through Python's Jinja package, which templates strings given a template. The template is present within the tokenizer or VLM's manually maintained templates. So we're wrapping the lowest level Jinja call with C bindings and using them directly for templating. So this is the second work stream or major work stream in the KV Cache Manager. I also wanted to point out that there's a roadmap issue or a technical roadmap issue or a proposal, which outlines some technical work we want to get done. If you're looking to contribute, you can. It has a lot of issues that are sort of good first issues that you can get started with. And you can also propose or follow up with any discussion in that issue. So going back to the first point, which is standardization of KV cache awareness, basically in VLM. So the pipeline I just mentioned is very, you need to be very precise when recreating it, because again, you have the KV cache indexing metadata in VLM, and unless you're reusing the Python code that gets you there, you have to recreate it precisely. Otherwise, you'll miss the KV block hashes. And considering that the main client for the KV Cache Manager, or at the moment, is the inference scheduler or the upstream gateway inference extension, which is in Go, we successfully recreated pretty much everything required so far. But as of now, we want to better standardize this work throughout the community. A first step in that direction is standardizing the hashing or the hashing of the tokens that form the KV block keys. So at the moment in VLM, what happens is there are two options available, two hashers available, one being the built-in hash function for Python, which is, as you can guess, very Python dependent, or made just for Python because it's built in. The second is SHA-256 that hashes the pickled representation of the tokens, and that is also hard to reproduce. So what we're starting with is introducing a third option, which is cross-language, specifically SHA-256 of the CBOR representation of the bytes, the concise byte concise binary object representation, and that's the first PR we'll propose to VLM on this end. The second would be aligning with LM cache or working with LM cache for alignment. So LM cache handles offloading and indexing outside of VLM, but basically within the process if you run it there, but in their cache engine. And in order to align the events or KV events that leave both VLM and LM cache, we need to align on the schema and we need to align on the hashing procedure. So this is one topic I wanted to raise here. Feel free to join the discussion. And obviously,
sorry,
all of this will be put in an RFC for VLM.
Sorry, Mer, sorry to interrupt. Like, do you guys plan to do this by you guys self, or do you want some help from the Mcache community to make the events between VM and Mcache aligned?
I think this is exactly the purpose of this conversation.
Mm-hmm.
We do think this should be a joint effort, especially with your team, and this is the forum for that. So I'll define an RFC. I'll open an RFC on this matter very soon. And
for sure.
the PR that we basically want to integrate the llm-d KV cache manager as one option and take it from there on the alignment on both the schema and the hashing of KV.
Okay, sounds good to me. Yeah, looking forward to the RFC. Yeah.
Yes, Neely, you had a question?
No, yeah, I just wanted to emphasize that I agree. I think that the KV events which expose the status of the KV inside VLM node is something standard that NVIDIA put in, but it's not, tight enough. We do want to see that this is used also by LM cache. And so the KV cache manager, which is able to consume that, will be able to have, a standard way of knowing how these KV events, because we need to recreate. Having this on the one hand exposed when we get a request, we need to be able to hash back and then do the matching. So there should be some stronger standard, and I think that's what Maroon and of course LM cache. It's important to learn. You also expose events, but there are not KV events.
Do you guys know what NVIDIA is using in Dynamo for the hashing? Is that
they're using Dynamo? Basically runs they run VLM by code, so they have access to all the
it's the same as VLM. Yeah, sure. Okay.
I think we can move on to open forum if there is nothing else on this.
Yeah, that's I think the idea. So I think this is the first thing we would, I think we see how it would be good to collaborate with LM Cache. But I think if you have other ideas, we are also open to see how we can, create better. I think both better integration and more functionality available by putting together LM Cache and llm-d in different scenarios.
Yeah, Clayton, you have some comments put up on Open Forum. Do you want to?
Yeah, so Rob and I are going through what do we do next in the roadmap, and we currently have nothing really called, I mean, there's some minimal stuff described in the roadmap for KV disaggregation. So as a SIG, my ask to the SIG is to like concretely, like, I want to get like a rough list of what would go into, what could we put in the roadmap? What's the end user benefit? Why it, like, we've got a lot of threads going on. I was actually having a lot of trouble kind of figuring out what we've agreed on, what we're doing, and like pruning. Like there's a lot of movement that has to happen at all these. I totally understand. Like we have a lot of complexity, but like I'm kind of taking the opposite perspective, which is what is the 3 priority ordered benefits we're going to give to end users in timing wise, and then what do we need to do to concentrate resources on that, and how can we accelerate it? So like the 3 I've seen are CPU cache offloading. That one's on track. What can we do to accelerate it? The other one is indexing and KV cache awareness to make better routing decisions. And I know that there was work going on to like get to the concrete, like what is the scope of it? Do we have the minimum viable thing that we can turn on? What are all the wrinkles? Was kind of having a hard time interpreting that from kind of the roadmap and the status. So like there needs to be something kind of at the project level that says what it is that we're delivering. That was kind of the third. And then the third one is we kind of had that tentative agreement, at least at the high level, on there's low latency offloading, and then there's everything else. Like getting to a place where we can define that in the north-south doc, we kind of have roughly those 3 items identified. Is there anything else that we're planning, and is that the rough priority order from the SIG? I just want to like try to like pull that up. Like, is that the word that we're going to propose? Is that something that Rob and I should make a case to be in the roadmap? Do we have a proposals and kind of the formal design that says exactly what it is we're delivering? Vita?
Yeah, I think I think it is, and I know we need to write it down, and there was other things, so we need to put it in the priority and write it down. I think the third one, maybe fourth one, that is lower priority, but it's more about east-west sharing, which is not through storage, so just sharing between different VLLM instances. I think this is something we also want to explore. It's on our list, but I think the first 3 is CPU offloading, KV cache indexing, and KV aware routing, as you mentioned. I think maybe we should, there are documents there, but maybe we should be clear about the steps and priorities we want to achieve. And the third is the shared storage integrations in a simple, or the most simple way that I think how I see it. And the fourth is east-west sharing between different instances. Danny, Maroon, are you in agreement on that?
I agree with that. I'll say about the east-west sharing that it's very enticing just as a big picture, but I'm not convinced yet that the use cases are strong enough to actually justify the complexity that it brings with it. Because it looks like the big picture is beautiful if you have an index that says where things are, and then you just hook up 2 endpoints and just talk and move KV values from one to another. High level, it's beautiful. When you get down to the actual details, it gets more complex. And then the question is, do we have good enough use cases to justify that? Especially if you have this avenue of shared storage that might kind of make it redundant or
Yeah, and we call this out a little bit in the North Star. The way that we do this internally is we use shared memory, and that is backed by shared storage. So there's reasons, like on the TPU architecture, like there's reasons we don't have local SSD, but we also see a lot of people using local SSD. So like I think I kind of agree with the priority order, just as like Danny, like I also had that concern about east-west, like in theory is great, but is operationally complex. And we kind of called that out a couple places. It'd be great to like get that succinct. My question maybe for Maroon as well, like, and Oz as well, is like, can we accelerate CPU offload by bringing more attention to it? And then what is left on KV indexing? That was kind of the two. And if there's anything, if there's a fifth or sixth item here, that'd be great. But
I
Yeah, so
think it's. Oh, go ahead, Mo.
acceleration on CPU offloading would be attending to the PRs, I'd say. So there are 6 open
Exactly.
PRs that are I'm not sure if they're being reviewed or only the RFC is being reviewed, but they can use some attention. The final PR would follow after because it's dependent on them of the actual implementation of the CPU offloading connector. The KV cache indexing is there is one more PR pending, which is in testing state. I didn't publish it yet because we were contemplating whether to implement a hack on what's missing in reproducibility of hashing or to start an RFC, and we chose to start the RFC on standardizing whatever is needed on the VLM side. So it will be followed, or at the same time, there will be a VLM PR for a new hashing function for prefix cache KV block hash calculation, and the PR will be open for public reviewing. So after that, we would have KV cache indexing that works both for GPU, for what's in the GPU, for the GPU cache, and the offloaded CPU cache. Then we will align or integrate with llm cache to use the same schemas and the same hashing.
Okay, and then for on KV indexing specifically, I think one of the questions is like, can we show what scenarios in the perf win through concrete, reproducible, whatever, relative to the approximate algorithm? Like I'm still looking for that
Yes.
like capsule. I think that would be
So
what I would put in the roadmap. Like I'd be like, improve observed traffic flow routing with precise, awareness retrieved from model servers, get XXX percentage benefit in YYY scenarios.
Yeah, so that's also running in parallel with it's an intersection with the benchmarking SIG to come up with these scenarios based on real world traces or real world use cases and execute them to collect this data on when it's useful and the value it adds.
But I think that's exactly, Maroon, and it's to us to do. That's exactly what we should specify, because I think this work that we are doing, we didn't share about, more use case sort of simulation for benchmarking, and then comparison of, more accurate KV cache routing with more estimation or approximations that we do through the prefix score, right?
Yeah.
So we should better document what are our goals and what we are doing, so it can be shareable with community, and then also get feedback. I think it's more done on the benchmarking scope, but it's very connected to the KV cache work.
Yeah, as long as we can, like, I want to put, if we put a roadmap item down, I want to have at least a placeholder that we are already confident that it offers a win somewhere. Or like, we need to keep doing the testing to like exactly quantify. That's fine. Neely, sorry.
No, that's okay. I was just saying we are working on that. The thing is that the platform for doing benchmarks are buggy. So we are working on that, fixing that, and we will. I think that we are now have something that we can work on, because we need to run those tests in a way that is reproducible and is, we have confidence in the results. So I think we are really close to being there, and we'd of course share the results.
So I'll take this rough ordered list. Is it fair to say the first two are the top priorities, and then the next two are they're the next things in the list, but we haven't gotten to. Okay, great. Thanks.
Exactly. Yeah. We're right ran out of time. So if there's any other topics or stuff people want to bring in, there's a Slack channel. Let's use that. Okay. So thanks, folks. Have a good day.
Thank you.
Bye.